the last few videos I've made, we've covered how to read and write chemical reactions. In this video, we're going to talk about the third type of chemical reactions. Before we get started though, I'm not going to walk you through how to balance equations. If you need help with this still, click the link in the top right corner. So just to review what we've already covered. Synthesis reactions occur when two pure elements come together to form a single compound. We use the illustrating of dating to show this. On the other hand, decomposition reactions occurred when singular compounds were broken down into its components. We use the illustration of breaking up with each other to explain this reaction. Now we can kick this up to a new level with single replacement reactions. Single replacement reactions can be thought of as a substitution. Think about playing a pickup game of basketball. You and your friends are in the middle of a game, and there is that one guy on the sideline that's been watching you the entire time. Part of the way through the game, that guy calls out and asks if anybody needs a sub. You at this point don't want to be rude, but to be honest, at this time, you're not tired or even want to sub. At this moment, you have a decision to make. Do you let this stranger substitute in for you and leave your teammates high and dry? Or do you be a jerk and dismiss this guy's request to join the game? A single replacement reaction is a lot like this. You have a happily bound compound, and a singular element wants to join in on the fun. If this reaction occurs, then there will be a result of a new compound and a new element by itself. Because of this, we use the equation AB plus C equals AC plus B to illustrate the point. To keep with our prior illustration of types of reactions, let's look at this from the point of view of dating. You and your significant other are happily dating, when all of a sudden you get a sneaking suspicion that he or she is cheating on you. You find out that your suspicion was right when you find him or her holding another person's hand. You realize then you are no longer in a relationship, and you leave brokenhearted. The original couple was the starting compound on the reactant side. The lone element that is also on the reactant side is the person who has taken your boo thing. Now on the product side, there is a new couple, which is the new compound, and you, the singular sad element. Now we know the skeleton and how to create single replacement reactions. We can talk about the rules for replacement. The biggest thing to remember in these types of reactions is like replaces like. If the compound consists of a metal and non-metal, then we are going to replace the portion of the compound that is similar to the singular element. If element C was a metal, then we would replace the metal portion of the compound to make your new compound. If element C was a non-metal, then it would replace the non-metal portion of the original compound to make a new compound. Let's look at an example of this with thermite. Thermite is known to release tons of heat and explosive potential. One example of this is in Breaking Bad, where Walt and Jesse are trying to break into the chemical plant to get their first barrel of methylamine. So the chemical formula for thermite is aluminum plus iron 3 oxide yields aluminum oxide and iron. When we look at this equation, we see that the lone element on the reactant side is a metal. This means it's going to replace the metal portion of a compound. So in our products, we are going to have two elements switch spots with each other, leaving us with iron by itself and aluminum with oxygen, making a compound called aluminum oxide. Once we finish, we balance this equation and we get 2Al plus Fe2O3 yields Al2O3 plus 2Fe. Let's take this up to another level with polyatomic ions. So we know that metals can combine with polyatomic ions to form ionic compounds. This can result in more than two elements within a compound. How then do we know what portion of the compound to replace? Follow the rules that like charges replace each other. Polyatomics have a charge. It can be positively or negatively charged depending on what polyatomic ion it is. So let's take an example of this. Copper plus silver nitrate gives us silver and copper 2 nitrate. On the reactive side, we have copper, which is a metal and is positively charged when it is in a compound. It will replace silver and silver nitrate because silver is the positively charged portion of a compound. Now let's work through a practice problem. Write a chemical reaction involving zinc and hydrochloric acid. First, I look at a problem and I see that it gives me an individual element, zinc, and a compound, hydrochloric acid. Zinc is a metal, but hydrochloric acid includes two nonmetals. So how do I know which portion to replace? I go back to the charge components. Zinc is positively charged when it is in a compound. So it is going to replace the positive portion of the compound. With this information, we can replace our hydrogen in the reactant with zinc atoms to produce our product of zinc 2 chloride and hydrogen. Now you should be able to work your way through single replacement reactions. I hope this helped you out, and good luck with your classwork. If you're one of my students or just want to watch related videos to this topic, click the playlist button on the right side of this screen. Finally, if you're just wanting to keep up with this channel, my latest video is going to be posted to the left of the screen. Once again, hey, thank you for supporting this channel. Thank you for supporting me, and good luck this year in your classroom.